Hey guys, welcome to the Linux course. So the next session for us is basics of shell. Now let's get into it. So first, we'll be looking at the Linux architecture. So Linux architecture in the sense, it is not an architecture which is built using hardware. So the hardware part is what you mean by the laptop's hardware or the CPU. So that is the middle part over here, hardware. So hardware just cannot contact with the users directly. So let's say if you just have a motherboard laying on your table, you cannot communicate with it. A motherboard or a microprocessor or anything, a complete setup is there, and you cannot you cannot communicate with it because there is no common language between you and that CPU. So to enable that, there comes kernel, which is the middleman, which basically contacts the hardware for us. So we are the users. We try to utilize few utilities or few applications. So let's consider the application is a calculator. So the calculator, as using the calculator, you want to do arithmetic operations. So now let's say this is the calculator. You are trying to use that application. So now the calculator will basically this is the application. So there are few commands within the Linux, and those commands are executed on an entity called the shell. So we'll see what is shell, but right now let's consider the architecture. So you have the applications and you have this shell after that. Shell basically executes your commands for you. It will basically communicate with the kernel for you. So as an end user, you see the shell, you type in a command or you type in something, or you just click on an application. The first instruction will be given to the shell. So the shell gets it. So let's say you want to copy a file. So you use the copy command. So shell knows that you're using a copy command and you're trying to copy a file to another file. So now the shell instructs the kernel. Basically it interprets the command and it instructs the kernel to do this particular operation. So kernel will understand what exactly is the operation and it will push that to the hardware, which in a language which the hardware can understand. So an assembly level language or something like that, or a microcontroller language. So it sends it to the hardware. So the hardware will do the operations for you, send it back to the shell, where you can view that. So as a user, you just know you type in the command, but you do not know what happens inside and what comes back. So you type in a copy command and you get the results in a fraction of a second, and you don't see what exactly happens behind. So you only see the monitor where you type in the command. You are typing the command on the shell, which is an interpreter for the kernel. So the kernel gets the command and knows what to do, and it does those operations with the help of hardware and then sends it back to the kernel, and which is visible on your shell, which you can see and understand that the operation has successfully happened, or if there is an error, you can see the error too. So this is the Linux architecture. So moving on, we'll first have to understand what is shell. So a shell interprets the commands you have entered using a keyboard and sends it to the operating system to perform them. So as we've discussed the Linux architecture, you have the shell and then you have the kernel. So both these entities, shell and kernel, are programs which are running on the operating system. The operating system is what making the shell and kernel possible. So kernel is trying to communicate with the hardware. Shell is the interface between the kernel and the user. So now what shell does is it interprets the commands which as a user you give into the system using the keyboard or the mouse. So shell interprets that, it understands what you're trying to say, and it translates it and sends it to the operating system. Operating system in the sense the kernel. So it sends it to the kernel. Kernel now understands what exactly should be happened. It uses the hardware help to complete those operations, and once it is done, it sends it back to the shell so that you can view it on your monitor. So the basic explanation of shell is this. You need to understand this. Only then you can go ahead with your Linux training. So we've understood what exactly is shell. Moving ahead, so nowadays, there is a lot of graphical user interface based Linux systems. So even CentOS is a graphical user interface based system. There is also a CentOS server, which is a command line interface, but there is also a graphical user interface. So like CentOS, there is Ubuntu, there is Red Hat, there is Debian, and there is Kali Linux. There is a lot of Linux distributions which have GUIs. So in a graphical operating system, how can you basically communicate with the kernel with the use of a shell? So to emulate the purpose of a server, to emulate the purpose of the command line interface, all the GUI based Linux distributions have a terminal within them. A terminal is basically an emulator or a duplicate of a command line interface. So if you click on the terminal, I think most of you would have seen this at least once. If you open the terminal in your GUI based Linux system, you will see a terminal like this. So there you will have your username at localhost, or any name, any of your system's name can be given here, and then you have this dollar symbol, and here you will have to enter your commands. So you can see I have entered the command called pwd, which means present working directory. This shows the present working directory, and currently the directory is /home/IntelliPad, so it's in the directory IntelliPad. So that's what it's showing over here. So this is the emulated version of a command line interface. So you can see here a terminal which we see in the GUI server emulates a command line interface Linux server. Terminal emulators are more commonly used now due to GUI operating systems like Mac or Windows or Ubuntu. So even in Windows we have a command prompt, even in Mac we have a terminal, even in Ubuntu or Cent we have a terminal which emulates or duplicates the purpose of a command line interface server. So now coming to top shells, we saw what is a shell and how does a emulator of a shell looks like in a GUI based system. Now we'll be looking at the top shells in Linux. So there is not just one Linux. As I told you, Linux is an open source system. So obviously there are a lot of contributors who creates different types of shells. So the most common, so basically a default shell you can say is bash, BASH, that is bash. The elaboration of bash is born again shell. Is a default shell in a lot of Linux distributions. So born again shell is the default one even in CentOS and even in your Ubuntu. In a lot of different Linux distributions, bash is the default one. You can further install other shells also. It is your wish. And then there is ZSH, which is basically Z shell, and it is similar to bash or an extended version of it. So basically, as I told you, they take the Linux operating system and create another Linux operating system which has better features. So like that, they took bash and made it better, or added few features like sharing your command history across multiple terminals. So let's say there are 4 different users using the same Linux operating system in different usernames. So you can share your command history to another user. So this is one of the features. There are so many useful features in Z shell. This is one of the useful features in Z shell. So that's what I wanted to share with you. So going ahead, there is fish, friendly and interactive shell. So it is again an extended version of the common shell, which is bash. So it has great features like auto completion of commands. So fish is an amazing shell. So fish has this ability to auto complete your command. So let's say you're typing in grep and your command is going on. So you do not want to type all of that. So if there is a command grep, if you just type gr and hit tab, you will get it auto completed. So it is like a IntelliSense. So it is like an IDE with IntelliSense. So you can use fish for that. And then TCSH, the next C shell, is an extended version of C shell. So there is another shell, basically CSH or the C shell. Basically, the C shell is written mostly on the C programming language. That is why it is called as C shell. And TCSH is again an extended version of the C shell. They've taken C shell and added more capabilities to it. So the plus of TCSH, it is a scripting language because it will be similar for the users who already have experience in C programming. So that's the benefit of TCSH. If you already have a good experience with C programming, if you know how to write code in C programming, so then you will find shell scripting pretty easy in TCSH because it might have the same method of writing. So that's what they're telling over here. There are still so many shells. You can just do a simple Google search and get to know about more multiple shells, but these are the top shells and these are the most popular shells. So that's why I'm showing them here. So going ahead, so this is the command which I executed in the previous window which I showed you while showing the GUI based terminals. So a simple command to interact with the shell. This command below provides the present working directory. So I wanted to show you an example of how you interact with the shell. So basically, if you type in pwd and you are interacting with the shell, when you hit enter, the shell understands that you are entering in a command. First, it validates the command whether this particular command is valid in this Linux distribution. pwd is a valid command. Then it further pushes it into kernel. Kernel gets it in and basically executes the command with the help of the hardware provided, and then it gives back the result to the shell, and shell displays it to you so that you can view it. So this is one of the examples which I wanted to show you. So guys, we have come to the end of this particular session. So meet you in the next session.